In this video, we're talking about how to use the zero theorem to find solutions or roots to a trinomial polynomial. So when we say trinomial, remember tri means three, so we're talking about three terms in a polynomial equation like this one. Whenever we see a trinomial, the first thing we want to think about is, can we factor it? So in this particular example, we have x squared plus 5x plus 6 equals 0. We want to see if we can try to factor the left-hand side. So we're going to set up our parentheses like this, and we want to figure out the factors of x squared. So what can we multiply together to get x squared? Well, that's just going to be x and x. And now what can we multiply together to get 6? Well, we've got a couple different options. We have 6 and 1, we have 2 and 3, but the only factors that we can multiply together to get 6 that we can also add together to get 5 are 3 and 2. So we're going to say x plus 3 times x plus 2. And we can always double check ourselves. If we multiply this back out, we say x times x gives us x squared. We say x times 2 gives us a positive 2x. 3 times x gives us a positive 3x, and 3 times 2 gives us a positive 6, and we see that we simplify to x squared plus 5x plus 6. So we can double check our factoring that way to make sure that we did it right. With our trinomial factored this way, we can apply zero theorem. And the zero theorem tells us that when we have two factors multiplied together and they're equal to 0, as long as one of the factors is equal to 0, this equation is going to be true. And that should make sense to us because if we imagine that this x plus 3 factor is equal to 0, then we're going to get 0 times quantity x plus 2 equal to 0. In other words, we're just saying x plus 3 equals 0, so we're substituting 0 for x plus 3. If we do that, we're going to get 0 times the quantity x plus 2. We'll still just have 0 on the left-hand side here, so we get 0 equals 0, and we can see that that's true. We can also say that if we set x plus 2 equal to 0, the other factor, then we know that this equation is going to be 0. So what we would get is x plus 3 times 0 equals 0. And of course, anything times 0 is still 0, so we're going to get 0. If you want to really make sure, you can use the distributive property and distribute this 0 across x plus 3 and get 0x plus 0 times 3 is 0, so we get 0. And as you can see, we just have 0 plus 0 equals 0, or 0 equals 0. So what we're saying is that the zero theorem allows us to set either factor equal to 0. If either factor is equal to 0, or if both factors are equal to 0, we know this equation will be true. We're going to set each of our factors separately equal to 0, x plus 3 equals 0, and x plus 2 equals 0, and then solve both of them for x. And the way that we'll do that, we'll subtract 3 from both sides. So we're going to say minus 3 on the left and minus 3 on the right, and we're going to get positive 3 and negative 3 to cancel. We're just left with x plus 0. Because 0 is the identity number for addition, we're just going to get x on the left-hand side, and over here on the right-hand side, we're just going to get negative 3. So x is equal to negative 3. For our second one, we'll do the same thing. We'll subtract 2 from both sides of our equation, and what we'll get is positive 2 and negative 2 to cancel on the left-hand side. X plus 0 is just x, equal to negative 2. And now what we have are two solutions to our equation, x equals negative 3 and x equals negative 2. These are the solutions or the roots to the polynomial equation we were given. And remember, the reason that they're solutions is because if we plug in x equals negative 3, here for our first factor, we'll get negative 3 plus 3, or 0. So that'll make this factor equal to 0. When we multiply 0 times the quantity x plus 2, we'll get 0 on the left-hand side equal to 0 on the right-hand side. And for here, x equals negative 2, that'll make our second factor equal to 0. When we multiply 0 times the x plus 3 factor, we'll get 0 on the left. So that's why those are the solutions to this equation. If you want to check yourself even another way, you can plug both of these back into the original polynomial equation. So for example, if we wanted to plug negative 3 back into our original equation, we should get 0 on the left-hand side. When we do that here, we'll get negative 3 squared, which is going to give us a positive 9. We'll get negative 3 times 5, which is going to give us a negative 15, and then we just have plus 6 equals 0. Well, if we do our addition first, we have 9 plus 6 is 15, so we get 15 minus 15 equals 0, or 0 equals 0, and that checks out. And we could do the same thing with negative 2, plug that back into our original polynomial equation, and we get 0. So those are the solutions to our equation. Let's do a second example quickly. If we factor this, we'll get x minus 2 times x minus 1. Negative 2 and a negative 1 is going to give us a negative 3, but negative 2 times a negative 1 gives us a positive 2, which is why the factoring works, and you can double check that if you want to by multiplying it out. So then we're going to set each of our factors equal to 0, so we're going to say x minus 2 equals 0, and we're going to say x minus 1 equals 0. Adding 2 to both sides, we get x equals a positive 2. Here, adding 1 to both sides, we get x equals positive 1. So we can say that the solutions, or the roots to our equation, are x equals 2 and x equals 1 for this polynomial equation.